Welcome to Machine Shop Channel. This is CNC Fundamentals, the foundation of modern manufacturing. If you've ever wondered how precision parts are made, you're in the right place. CNC's Computer Numerical Control is a manufacturing process where pre-programmed computer software controls the movement of machinery and tools. These machines follow a prepared program consisting of coded alphanumeric data. CNC systems can control various functions, including tool motion, workpiece positioning, and parameters such as feed rate, cutting speed, and tool engagement. Functions like spindle activation and coolant flow are also managed automatically. CNC technology offers several advantages: high manufacturing accuracy, shorter production time, reduced human error, ease of programming, capability to handle complex geometries. However, there are some disadvantages: high initial cost and the need for skilled operators. Maintenance can be expensive and technically challenging. Basic knowledge of computers and programming is essential. CNC machines are controlled using G codes and M codes, which are sets of numeric and coordinate-based commands. Each code corresponds to a specific action or movement. These can be entered manually by an operator or generated automatically by CAM software. G code generally handles movement and positioning, while M code controls auxiliary functions. CNC machines offer automated movement of tools and materials. They can operate in 1 to 5 axes, depending on the machine's complexity. A central machine control unit, or MCU, manages all operations. Motors and actuators drive movement, while sensors provide feedback for precision. Automatic tool changers, often called tool magazines, improve efficiency and reduce downtime. Modern CNC machines can perform 3-axis to 5-axis machining operations. This allows for more flexibility and the ability to machine complex parts with high precision from multiple angles in a single setup. CNC machines are classified according to their rotary and linear motion. There are 3 basic types of linear motion, which include X left to right, Y front to back, and Z up and down. Machines with only 3 axes X, Y, and Z are usually used to make simple parts on a single plane. The addition of a 4th axis, the axis, permits multi-sided machining by rotating the workpiece. Meanwhile, 5-axis machines also include B and C axes, which enable simultaneous rotation and linear movement of tool. This capability allows complex shapes to be machined with less setup. CNC instructions are called part program commands. Each program runs line by line, with each line referred to as a block. Each block contains words, which start with a letter and are followed by a numerical value. These words collectively define tool paths, speeds, and actions. Let's examine a typical CNC program line. Here's what it means. N001, sequence number, G91, incremental positioning. X, Y, coordinates, F100, feed rate. S100, spindle speed, T01, tool number. M03, start spindle in clockwise direction. Each character and number plays a key role in defining the machine's behavior. G code, short for geometric code, is a programming language used to control CNC computer numerical control machines such as mills, lathes, plasma cutters, and 3D printers. It tells the machine how to move, including directions, speeds, locations, and tool operations. Here are some commonly used G codes. G00, rapid positioning. G01, linear interpolation. G02 and G03, circular interpolation, clockwise and counterclockwise. G20, G1, switch between inch and metric systems. G81 to G87, various drilling and boring cycles. G90 and G91, absolute and incremental commands. These codes control how the tool moves and interacts with the workpiece. M code stands for miscellaneous code. It controls machine functions such as coolant on-off, spindle on-off, program stop, etc. It's used alongside G codes, which control movement. M codes handle auxiliary functions. M00, program stop. M01, optional stop. M03 and MO for spindle direction. M06, tool change, M08 and M09, cool and on-off. M30, end and rewind the program. These functions help automate the overall machining process beyond just cutting. The flow of CNC programming starts with designing the part in CAD, then converting the design into a CAM program. From there, G-code and M-code are generated and uploaded to the CNC machine. After setup, the machine runs the program, executing operations with precision and repeatability. For a more detailed walkthrough on how to generate G-codes, be sure to check out our tutorial videos on our channel. That's it for this introduction to CNC Milling Fundamentals. If you found this video helpful, don't forget to like, share, and subscribe for more CNC tutorials and engineering content. Thanks for watching.